Greetings guys, this is Magnanimous Minds Lectures Online. We are back again with industrial electronics and for circuits using complex numbers. We are given a circuit here, an AC circuit with resistors, capacitor and inductors, and we are told for the first question we're told to calculate the impedance. Calculate total impedance. Question 2, total current. And then to calculate the total impedance, we know that if we are given capacitors and inductors, we are going to have like a complex impedance. That means like it has to have a real number and also the complex number, because according to the formulas, ZL, which is the impedance of an inductor, equals to 2 pi equals to G 2 pi FL, and ZC equals to 1 over G 2 pi FL, which makes it negative G over 2 pi FL. So for this case, this is similar to JXL, and this is negative JXC. So because of this, the impedance of a capacitor is always negative J, and that of an inductor positive J. So with this, if we consider this first branch, and there's the second branch, this is the third branch, we realize that 1, 2, the second and the third branch are in parallel, and their total is in series with the first one. So to calculate that, we are going to say ZT equals to Z1 plus Z2 times Z3 over Z2 plus Z3. And then what is our Z2? Z2, we've got a capacitor, so it's going to be negative, and then we've got a resistor, so we're going to have 3 for the resistor, minus 15, because we are given this in ohms, so this is XC, and we just put the negative J, so it's going to be negative J, negative 15J in rectangular form, and Z3 is just an inductor, which is going to be 5G. And then we have, since like we are dividing and multiplying here, we have to convert this to polar form, and also have Z2 plus Z3, which is 3 minus 15G plus 5G. Then to convert this to polar form, we simply say shift pole, and punch in the first one is 3, shift comma negative 15. This gives us 15.297, and the angle is negative 78.69. Then for this one, it's going to be shift pole, we've got 0, shift, and we've got 5. Then this is going to be 5, angle 90. Addition of this is going to be 3 minus 10, which in polar form it's going to be 3 shift negative 10. It's going to be 10.440, and the angle negative 73.30. This is ohms. So to get ZT, we're going to say ZT is to Z1, which is 6 plus 10G plus 1578.69 times 5T all over 10.440 to 70.30. ZT equals to 6 plus 10G plus, then we write this as it is 440 70.30. Then since these two are multiplying, we are going to multiply the coefficients, which is 15 times 5, so it's going to be 75, and we add the angles, which is negative 78.69 plus 90, which gives us 11.31, and then going further, it's going to be ZT equals to 6 plus 10 plus, and since these are dividing, we're going to divide the R's, which is I call them coefficients, but it's R's. It's going to be 75 divided by 10.44, which gives us 7.184, and we subtract the angle, so it's going to be 11.31 minus 70.80. This gives us what's going to be minus, it's going to be positive 81.61. Then to add these two, we take this one back to rectangular, so it's going to be 6 plus 10G plus, and take this back to rectangular, you say shift rect 7.184 shift 81.61, and then this gives you 1.048 plus G 7.107. Therefore ZT equals to, you add the real numbers, 7.048, and the complex numbers are going to be 17.107 ohms. And then we are told to also calculate we are told to also calculate the current, the total current. So to do that, to calculate the total current, what we are going to do is convert the ZT to polar and then calculate the total current. So we're going to say ZT equals to, and converting to polar, we're going to say shift pole 7.048 shift 17.10. This gives you 18.50 to 67.661. And then for total current, V equals to IZ, which is impedance. I equals to V over Z, and our V is 220 and its angle 0 over our impedance, which is 18.502 and an angle of 67.61. This simply, we divide these two, it's going to be 220 over 18.502 equals to 11.891, and the angle 0 minus this is just going to be minus 67.61 amps, and that's our IT. And that's it for this question. So what you do to get your Z impedance is that, like, you multiply these two over the sum of these two, since they're in parallel. That's what I did here, and I added the answer to this because this whole block is going to be in series with this one, so I added the answer. Then that's where I got the final answer, and then from there converted it to polar again. Then V equals to IZ, I equals to V over Z, and then that's our V 220. It's in phase, that's why it's 0 over our Z, and then that's our current over there. And that's it for this question. Please do subscribe to our channel as well as liking our videos. Also do follow us on our social media platforms. On Facebook we're Magnanimous Minds, Instagram magnanimous_mean, Twitter we are at magnanimous mean 1. Thank you for watching our videos.